Let's take a look at what happens during a phase change. Three basic states of matter are solid, liquid, and vapor. In the solid phase, the particles are aligned in an ordered array, as in this ice crystal. In a liquid, the particles are still fairly close together, but are not ordered in the same way that a solid is. In the vapor phase, the particles have moved much further away from one another and are freely moving and non-interacting with each other. One of the major differences between the three states of matter is the distance between particles, where the energy is at a minimum. So the equilibrium distance between particles in general is much, much further away for a gas than it is for a liquid or a solid. In addition, the solid typically has strongly interacting particles, and therefore the minimum energy is at a lower level than for a liquid or a gas, where the particles are not interacting as strongly with one another. Thus, fundamentally, to undergo a phase change, say from a solid to a liquid, we must input energy and move the particles further away from one another. Let's take a look at what happens when I input energy to an ice crystal. Notice that the water molecules are going to begin to vibrate about their positions in the crystal. And when those vibrations get enough energy and have a high enough amplitude, the hydrogen bonding network will begin to break up and the molecules will begin to move past each other and form a liquid. Let's take a look at what this looks like. So we have the collective vibrations of the molecules in the solid. Those vibrational amplitudes are getting larger and larger and eventually break apart. And those vibrations in the crystal, which we can describe as frustrated translations, turn into translations and rotations in the liquid droplet. If we continue to add energy to the liquid, we will see that those translations and rotations become more and more energetic, and as the kinetic energy of the translations and the rotations becomes large enough to overcome the intermolecular potential energy, the molecules begin to fly apart and form a vapor. Thus, we can see that a phase change occurs when the total energy in the system is enough to overcome the potential energy of interaction between particles. At that point, the average kinetic energy of the solid particles will be equal to the average kinetic energy of the liquid particles, and so there will be a temperature at which the liquid and the solid coexist. This is the temperature of the phase change, or the melting temperature. Likewise, there will be a temperature where the vapor and the liquid can coexist, and this is what we call the vaporization or boiling point temperature. The phase changes, which you are probably familiar with, are shown on the following figure. We can go from a solid to a liquid, as we just discussed, and that's melting. When we go from a liquid to a gas, that's vaporization. If the gas becomes a liquid, that's condensation, and when the liquid becomes a solid, that's freezing. We can also go straight from a gas to a solid, that's called deposition, or from a solid to a gas, and that's called sublimation.